Okay, Trig. I'm going to start 4-7 notes with you today. A little bit of a long homework assignment, but we'll only get through part of this today. And I'm going to start, so if you want to pause that to write those down, go for it. But I'm going to start, this is inverse trig functions, I'm going to start this with example 9. So go to the very back. We're going to start and we're going to do example 9 first, and then we're going to backtrack. So we're going to go to example 9, and then we'll go back to the very beginning because I'm going to show you why inverse trig functions exist. And some of you, and most of you, should know this already. If you've had geometry or you just are taking geometry this year, some of you, you just recently did this. But here is inverse trig functions. Okay, your inverse trig functions, like we're going to talk about just specifically inverse sine, inverse cosine, and inverse tangent, right? Sine, cosine, and tangent, those are the normal guys, right? But inverse sine is, it looks like sine to like the -1 power is what it looks like. Like the inverse of f of x would be f inverse of x. It looks like to the -1 power, right? These two are inverses of each other, right? So inverse sine, inverse cosine, inverse tangent. Sometimes they are also called arc sine. That means inverse sine. These two are the same thing. Or they're called arc cosine or arc tangent. If they call them that, that means the same thing as inverse tangent, right? It's just writing it in different words, I guess. So the reason why those functions, why this stuff here exists, is for this story problem right here. All right, let's draw a picture. A yardstick, straight up and down, casts a 4-foot shadow. Okay, 4 feet shadow. I'm making this into a right triangle. When the sun is at an angle of elevation, here's my sun, at an angle of elevation of however many degrees. So an angle of elevation is from horizontal up, right? So that's the angle of elevation up to the sun. The sun is shining and casting a shadow here, right? Okay. Determine the angle of elevation of the sun to the nearest 10th. Let's see. To the nearest 10th of a degree. A yardstick. Oh, ha. I'm like, where's my other dimensions? A yardstick is 3 feet. That was silly. I'm looking for my other number, and I'm like, where's my other number? A yardstick. Okay, 4-foot shadow, 3-foot yardstick. Great. They're wanting us to find this angle right here. So we would set this up using normal SOHCAHTOA stuff, SOHCAHTOA, which I think we've done. Have we done SOHCAHTOA stuff in this class? Yeah, we have. This one is going to be opposite and adjacent, so we're going to do tangent. And we're going to say tangent of the angle, which we call theta, or you can call it x if you want to, it doesn't matter, equals, the opposite goes on top, adjacent goes on bottom, so 3/4, right? We have to find a way of figuring out how to solve for theta, right? So how do I get rid of tangent? I can't just divide by tangent because tangent means nothing unless you're taking tangent of something, right? So what I have to do in order to get the tangent to go away is I have to do the inverse tangent, right? Tangent and inverse tangent cancel each other off, but I've got to do it to the other side also. So theta is equal to the inverse tangent of 3/4. And I got to get my calculator out. If you want your answer to be a decimal, or a degree measurement, you're going to want to have your calculator in degrees. If you want a radian measure, like a decimal number for radians, whatever, like pi over 3 or pi over 6 or whatever, it'll give it to you in decimals. But if you want that, you need to have your calculator in radians. I want degrees, so I'm going to make sure I'm in degrees. I hope I am. Let's go inverse tangent. I'm going to go 3/4. Inverse tangent. And I got theta to be, your inverse tangent should be like second tangent, by the way, 36.9 degrees. And I don't know, to the nearest 10th of a degree, so 36.9 degrees. That is why the inverse operations exist, is so that you can find your angles instead of just solving for sides. Normally we would be solving for a side or something. Here we're solving for angles. Okay, so that's why the inverse trig functions are important. That's why they exist. you maybe knew how to solve that already. Great. We're going to dive more deep into inverse trig functions so that we can see how those work. So example 9, yeah, not too bad. All right, let's go back to example 1. And let's talk a little bit more. Actually, before example 1, they go to the very first page. So there's a homework assignment again. Inverse trig functions. Let's talk about sine. This is what the graph of sine looks like, okay? When you invert something, you reflect it across the line y equals x. Okay, if I take this curve, you don't need to write this down. If I take this curve and I reflect it, the inverse is going to look like this. Ooh, something like that, whatever. It's going to go that direction. Actually, it'll be a little bit better like this. I don't know. Let's go, I don't know, like this. It'll go like this. Whatever. It'll be better like that. Anyway, the problem is this curve that goes vertical now doesn't pass the horizontal line test. So what I have to do is I have to restrict the domain of it. And so we're saying we're only going to do the inverse trig function, but we're only going to do like this chunk of it from here to here, right? Which would actually go from like here to here, right? So we're going to cut it off so that we're only looking at this chunk right here. And the rest of this basically doesn't exist because if I don't section it off like that, it won't pass the horizontal line test. So here's the deal, and here's how this works. We chunk it off between negative pi over 2 to positive pi over 2. So like right here, from here to here. Negative pi over 2 to positive pi over 2. That way it doesn't repeat itself and we don't have problems with it not passing the vertical line test. So on your unit circle, let me just show you how this works. Okay, if I wanted to say sine of, let's say, 30 degrees equals 1/2, that's what it would be, right? Sine is the y-coordinate. Sine of 30 degrees equals 1/2, okay? Let's say I was trying to solve for this angle. So I want to know sine of what angle is 1/2, right? Another way of saying that, another way of solving for x, is saying x is equal to the inverse sine of 1/2, right? Like I inverse sine, I do inverse sine to both sides, right? And I'm trying to solve for x, and x would be 30 degrees. But the problem is, there's also another place on this unit circle where sine is also 1/2, and it is at 150 degrees, right? It's also 1/2 at 150 degrees. But if I do inverse sine of 1/2 in my calculator, it will only spit out one answer, and that one answer is 30 degrees. Because I have restricted the domain, and your calculator is set up to know the restrictions of that domain, so that it will only reveal 30 degrees as your answer, and it will not give you 50. Like your calculator doesn't give you two answers, right? It only gives you one. So 150 is not going to be listed as an answer because inverse sine only exists from negative pi over 2 to positive pi over 2. Negative pi over 2 is another way of saying 3 pi over 2. So inverse sine only exists in the first and fourth quadrant, right? That's the only place that inverse sine lives. So eventually on your unit circle, we're going to write in here, in addition to this stuff, and we're going to write what quadrants inverse sine lives in. Inverse sine lives here, and inverse sine lives here. So if I were to ask you, find me inverse sine of, I don't know, let's go square root of 2 over 2, right? Okay, he's either going to be this guy, or he's going to be this guy, because sine is the square root of 2 over 2 in those two places. But inverse sine only lives over here, so the only answer is 45 degrees. It is not also 135 degrees, because your calculator will only spit out that, right? Because inverse sine only lives in the first and the fourth quadrants. So that is why, and again, it goes back to the whole, we don't want it to repeat because then it won't pass the vertical line test, and your calculator can't spit out two answers at one shot. So we go from negative pi over 2 to positive pi over 2, which is the first and the fourth quadrant, okay? That was a really lot of information all at one shot. Hopefully that made sense. I can go over that again tomorrow when I'm back, but that's how that boils down to. Okay, so we're going to use our unit circle to figure out this stuff, all right? So they are wanting us to find arc sine or inverse sine of negative square root of 3 over 2. And again, this means that, sine of some angle x equals negative square root of 3 over 2. I'm just trying to figure out what that angle is, right? So I do the inverse sine of negative square root of 3 over 2. So I'm going to use my unit circle to do that. I'm going to go down to my unit circle. I want to know where sine is negative square root of 3 over 2. Okay, so there's two places on the unit circle that it's negative square root of 3 over 2. It is right here at 240 degrees or here at 300 degrees. But if I do it in my calculator, if I take inverse sine of negative square root of 3 over 2, my calculator will only spit out 300 degrees because inverse sine's domain is only the first and the fourth quadrant, not in the third quadrant. So what I'm looking for here, find the exact values or state the value. I don't know why they say values because there's only one value. Or state the expression is undefined. We want to say x is equal to 300 degrees. Or maybe when they say values, they mean find also the radian version. The radian version will be 5 pi over 3. But 5 pi over 3, they won't call it 5 pi over 3. They'll call it negative pi over 3. Okay, because it's going from negative pi over 2 to positive pi over 2. Instead of calling it 3 pi over 2, they call it negative pi over 2. So I know that was a little bit confusing, but instead of saying 5 pi over 3, they'll say negative pi over 3, which is the same thing as 300 degrees. Okay, a little bit confusing. All right, B, let's go arc sine of 1/2. This just means sine of some angle is 1/2. We're trying to find what that angle is. So we do the inverse sine of the arc sine, and I want to know where it's 1/2 at. So I'm going to go to my unit circle. I'm going to find where my halves are. 1/2 here and 1/2 here. Hey, we've already done this one. Okay, is it 30 degrees or is it 150 degrees? I don't know. It's going to be 30 degrees because inverse sine lives in the first quadrant, so it's either going to be 30 degrees or pi over 6. 30 degrees as a degree, pi over 6 as a radian. Either one of those. It might, I wonder if it will tell you on your homework assignment. I bet it will tell you whether it wants radians or degrees. Whatever. All right, part C is a little bit confusing. They're saying inverse sine of 2. That means sine of some angle x equals 2, and I am trying to find what this angle is. Except the problem is, I don't know where 2 is at for a sine value on my unit circle. Like, what the heck? Okay, let's think about this also. If I were to graph sine looks like this. So I want to know where the y-coordinate, this goes to -1. Where is the y-coordinate touching 2 at? I want to know, like, where are the y-coordinates touching 2? Well, the highest sine goes as 1, and the lowest it goes as -1. So this one is undefined. There is no solution to this one because it's never going to touch 2. It never goes higher than 1 or lower than -1. So that was kind of a trick question on part C. I think you do have one of those on your homework assignment, so be careful of that. Any values that are for sine and cosine that are above 1, you cannot evaluate, so there's just going to be no solution. All right, let's go down to cosine. Cosine is the same way. Cosine does this little curvy thing. And so when we do his inverse, okay, his inverse is going to do one of these things as well. So we have to restrict that domain again, otherwise he's not going to pass the vertical line test. And they restrict the domain going from 0 to pi. So on your unit circle, the inverse, let me get rid of all this junk in here. Hold on a second. Get rid of all the little loops. Okay, inverse sine lived in the first and fourth quadrant. Inverse cosine goes from 0 to pi, right? Here's where inverse sine lives, in the first and fourth quadrant. Inverse cosine goes from 0 to pi. So I'm going to do inverse cosine and inverse cosine. He is going to be in the first or second quadrant, okay? So if they say, I want to know where inverse cosine is 1/2. Well, he's 1/2 here, or he's 1/2 here. So is the answer 300 or is the answer 60 degrees? It's going to be 60 degrees because inverse cosine lives in the first and second quadrant, okay? And again, we're restricting that domain so that he doesn't repeat when so he doesn't fail the vertical line test, basically. We lump him off, so we're only looking at, like, this little chunk of it, right? Okay. Let's do an example. Find the exact values. I got to keep going back and forth. So we're doing inverse cosine of -1/2. All right, -1/2 for cosine. Cosine is the x-coordinate, by the way. -1/2 for an x-coordinate. Oh, right here. -1/2, but then also -1/2 here. So is it 240 or is it 120? It's got to be 120 because 120 lives in the second quadrant. So it's going to be 120 or in radians is 2 pi over 3. 120 or 2 pi over 3. We'll list both of them. Whoa, that's not the right spot. 120 or 2 pi over 3. Okay, those two answers. All right, now they're going tangent on us. They want to know where tangent is the square root of 3. What angle gives me a tangent value of square root of 3? Tangent square root of 3 here. Tangent is square root of 3 here. And he's negative here, so that doesn't count. And he's negative here, that doesn't count. So he's either going to be 60 degrees or he's going to be 240 degrees. Oh, shoot, I didn't tell you what quadrant's inverse tangent lives in because we have to restrict his domain as well. He has the same as sine. So inverse tangent lives here and inverse tangent lives here. So if it's not in the first or the fourth quadrant, it's not going to count. So 240 is not going to be the correct answer. It's going to either be 60 or pi over 3 if they want in radians or degrees. So 60 degrees or pi over 3. Okay, that's inverse tangent. He lives in the first and the second quadrant. Inverse tangent, inverse sine, and then inverse cosine lives here. Okay, kind of confusing. That's how we lump off his domain restricted. Yeah, inverse tangent goes from negative pi over 2 to positive pi over 2. That's what he will look like. Same thing with sine. He goes from negative pi over 2 to positive pi over 2. And then inverse cosine goes from 0 to pi. So that's that little box right there. All right, arctangent of negative 1. So they want to know where tangent is negative 1 at. Sorry, I'm making you really dizzy here. Where is tangent negative 1? Where is tangent negative 1? Right here at 135 or right here at 315. Okay, which one is it going to be? Tangent's only in the first and the fourth quadrant, so it is going to be at 315 degrees or at 7 pi over 4. Now, they won't call it 7 pi over 4. They'll call it negative pi over 4 instead. So 315, I guess if they do that, then they should call it negative 45 degrees, right? Technically. If you say 7 pi over 4, I'm not going to count it wrong. It'll be, yeah, that'll be right. So 315, 7 pi over 4, which is the same thing as negative 11 or negative pi over 4 and negative 45 degrees. Whatever. Okay. All right. Let's do a little bit more and then we will stop. Use a calculator to approximate the value in radians and degrees. You know how to do this already. You're just going to go second tangent and we're going to do radians and then we're going to do degrees. Okay. So inverse tangent of 5.69. Let's see if I can figure out how to do this. I want to be in 5.69 second tangent. I got 1.3. I'm going to go 1.40. Does it tell? No, it doesn't tell many decimal places. We're going to go 1.40 because it's like 1.396. So we'll go 1.40. Now, before I do degrees, I don't know if you remember this, but 1 radian was like 57.3 degrees or something like that, right? So if I have 1.4, that's going to be like maybe, I don't know, 80 degrees, something like that. Maybe close to 90 degrees is what he will be, like 85 degrees, something like that, okay? So switch back to degrees on your calculator and go tangent of 5.69, inverse tangent of 5.69, 80.03 degrees is what he will be, okay? Same thing with cosine. We're going to go inverse cosine of negative 3/8. And we're going to go inverse cosine. The radians is 1.96. Okay, that's almost 2 of these. So 2 of those would be like 114 degrees, right? So let's do that again. Inverse cosine of negative 3/8 is 112.02 degrees, right? We said 114, almost 114 degrees. Okay, last one's arc sine. So again, arc sine means the same thing as inverse sine. Like they're both inverse sine. Okay, radians versus degrees. We got negative 0.6. And we're doing inverse sine negative 0.64. So this is a negative degree, right? Because I told you, like, a lot of times they'll write it as negative degrees instead of writing it as like 300 degrees. So negative 0.64, that is all like a little over half of a degree. So like maybe a little less than 30 degrees, 25, something like that. Negative 25 degrees. Let's see what we get. Oh no, 36. Oh, it's over half, not less than half. 36.9 degrees is what he is. Okay, so there you go. Radians, degrees, you're just switching back and forth in your calculator. But I always like to do that little mental check to see, 1 radian is that much. So my degrees should kind of reflect that. Okay. Yeah. Let's stop there. I don't want to do example 4 yet. So we'll stop right there with example 3. You should be able to do a decent-ish chunk on this homework assignment. Maybe like up through 24. Let me see if I have it pulled up. Oh, shoot. You should be able to do, I don't know. Yeah, you should be able to do up through 34. So right here is the cutoff. That's where you should be able to do. So work on those problems for homework. Don't do anything past 38, but you should be able to get through some of those other ones up front. Actually, you should be able to do 78. 78 was the story problem example. So if you want to go back to 78 and do that one as well, that one might be the easiest one total for you. So there you go. Work on those with whatever time's left in the period. There you go.